So this handout that you have is a review of all types of factoring, right? We need to be pros at factoring by Friday. So first thing is to change this 8.5, scratch that out. It's really notes on all of factoring of chapter 8, which is actually 8.5 to 8.9. And today we're actually going to cover 8.8 and 8.9 together. So just to quickly review what factoring is, it's a reverse distributed property. We already know that the first type of factoring we learned was factoring out the GCF. So let's practice right here with number 1. What's in common in all three terms?
2.
Definitely a 2, but there's also an x. So if I do pull out a 2x, what's left over on the inside? 2x to the 4th. And then the middle term? Negative 3 with an x. And the last term? Negative 4. Perfect. And that's about it, guys. Now, what you should do after pulling out the GCF is look at the inside and see if you could continue factoring, which you cannot, right? So let's move on. It does say right there, we could do more examples, but I'm not going to. It says, always check on the inside of the parentheses and see if you could continue factoring. This is called factoring completely. So, for example, right here, I give you an example where we pull out the GCF from all three terms, which is a 2x. And on the inside, you have left over x squared plus 1x minus 20. So let me underline that in blue. As you can see, the a value is 1, so it's really easy to continue factoring, right? When you factor a quadratic trinomial, when your a value is 1, it's really easy because you could set up parentheses, x, because x times x is x squared. And all you have to do is think what times what is the c value that if you combine together is the b value. So what times what is negative 20 that if you add together is positive 1? You could already see the answers here, right? Positive 5 and negative 4. So, of course, that's the setup. But don't forget to bring down what most students make the mistake of. They pull out the GCF first, and they forget to bring it down. You need to bring down that GCF if you pulled it out originally. Does that make sense? Yeah. So that's called factoring completely. And, again, always start by trying to pull out the GCF. Always look at the inside of the parentheses and see if you could continue working, which you cannot. Okay. Factoring quadratic trinomials when the a value is 1, that's like the easiest thing, the easiest type of factoring. Okay. When there is, if you have a 6 right here, you have to do that long process. That's ugly. That's horrible, right? But it's 1, it's nice and easy. You just set up your answer format, x right here, x right there, and you simply think what times what is negative 12 that if you combine together is positive 1. What do you say?
4 times negative 3.
Positive 4 times negative 3. Okay, now if you're confused, go ahead and make a list of all the multiples of this guy. So if you're confused, go negative 1 times 12, negative 2 times 6, negative 3 times 4. Those are all the possibilities. And if you start adding them to see which one gives you the b value, which is 1, that gives you 11, didn't work. This gives you 4, doesn't work. This one gives you 1. So that's a correct pair of numbers you want to plug in. So those are like the easiest. And I'll tell you what, it's a 20 question test Friday, 20 questions. And the most type of question that you'll see is this type, the easiest, right? Where you think what times what is the c value that if you combine together is the b value. Let's try this one. Now on this one, what times what is the c value that if you combine together is the b value? What is the b value on number 2? Is there a middle term? No. So that means that the middle term is 0. All right? So right here we're actually thinking what times what is negative 25 that if I combine together I get the middle term. What's the middle term? 0. So what times what is negative 25 that if you add together is 0?
Plus 5 to negative 5.
Plus 5 minus 5. And it doesn't matter if you put the minus first or the plus first. It's the same difference. That's your factored form. Okay. And this is actually a type of problem we're going to be doing on today's section. We'll get to that later. How about this guy right here? Again, it's Beautiful, nice and easy. My favorite types of factoring problems. Why? Because the a value is 1. So all you do is think what times what is 32 that if you combine together is negative 18. And if you're stuck, make a list, right? If you're not good at this, make a list. How could I get 32? Well, 1 times 32. 2 times 16. 3 times, nope. 4 times 8. 5, 6, nope. So that's it. Which pair of numbers combines together to give us negative 18? This gives me 33, no good. This gives me 12, no good. This gives me 18, but it gives me a positive 18, and I want a negative 18. So we have the right numbers, we just have the wrong signs. Switch it to a negative and a negative. Plug it in, negative 2, negative 16, and we're done. Easiest type of problem. That's the most of the questions, the majority of the questions when it comes to separating them in different topics. This is the most that you'll see, the easy type. Now, there are some that are difficult where, let me see, like right here. This one's not as easy. Why is it not easy? Because your a value is 6, right? So you can't do this. You can't do x. Why not? Because x times x is not 6x squared. So this 6 messes it up. So what we need to do is, let me just scratch this out. What we need to do is that long process. Now you could do either by grouping or that kind of shortcut method. Now the shortcut method is not on this worksheet itself. The shortcut method is right here. This was the alternative to factoring by grouping. Now it's the same first 2 steps. Step 1, a times c, get a number. Step 2, make a list. Think of the multiples of that number that combine together to give you b. Step 3 and 4, you jump straight into your answer format, and then you reduce your binomials. So I hope you guys are comfortable with this new simple method. Let's do that on this one, because we said this is the hardest type of problem there is. Step 1 is to multiply a times c. So what do I get?
Negative 18.
Negative 18. Step 2, let's think of the multiples of negative 18 that combine together to give me the b value, which is negative 7. So let me go negative 1 times 18, negative 2 times 9, negative 3 times 6. Those are all the possible ways I could get negative 18. Which pair of numbers gives me a negative 7 if I combine them? Negative 2 and 9, but switch the signs. Thank you. So if I did add 18 and negative 1, that's 17. That's definitely not negative 7. This, if I add it, it gives me 3. That's not 3 up there. 2 and 9 gives me 7, but I want it to be a negative 7. So I want to make it a positive 2 and a negative 9. That way it really does give me a negative 7 when I combine it. So if you were to do grouping, it would still be a long process from here. You'd have to change your trinomial to a polynomial. That way you could factor by grouping. But the quicker method is to jump straight to your answer format. Okay? Now, do you guys remember what is the first term that goes right here and right here? 6x. So just to teach it again, you go to this first term and you're going to copy it exactly the way it is right here, but you're not going to use a square. Okay? We're just going to take the 6x, put a 6x here, and put a 6x here. And now you might be thinking, wait a minute, that's not going to work. Yeah, it doesn't work right now because 6x times 6x is 36x squared. That's why we need to reduce. Step 4 says reduce. So we'll get to that later. But right now we need to fill in these blank spots. And what do we put in these blank spots? The 2 and the minus 9. So this positive 2 goes right here. This minus 9 goes right here. So now that we have that, that was step 3. Step 4 is to reduce each binomial by dividing it by its GCF if possible. So you want to reduce each binomial. So on this first binomial, we have a 6 and a 2. What could I reduce by? 2. And on the second binomial, I have a 6 and a 9. What could I reduce by? 3. Okay, so what will our answer be? 3x plus 1, 2x minus 3. Not bad, huh? So that was a review of pretty much everything we've done so far. And we could practice more, but nah, Let's jump to the back side. We'll get back to the new part that we haven't done yet. Let's jump to the back side. So on the back side, it just explains the zero product property. And we've been using the zero product property on this whole second half of chapter 8. And that's where you have equations. And if you do have something times something equals 0, you could split them. So as you can see on this example, I have a quadratic trinomial. The a value is 1. That means it's really easy to factor. All you have to do is think what times what is negative 12, that if you combine together is positive 4. So what times what is negative 12 that if I add together is positive 4? The answer is right here. Positive 6 and a negative 2. If I multiply these guys together, it will give me the negative 12. If I add them together, it does give me the positive 4. Now that it says something times something equals 0, now you could split them and set them each equal to 0. And then you solve each equation, simple equation, and you get two answers. So we already have seen that. Like I said, I'm just reviewing. And sometimes you'll have equations, like on this one, we have to do that long process of factoring because the a value is not 1. And I also want to remind you, sometimes, guys, we don't have it equal to 0. Like you might have let's say a positive 6 over here. So then you would have to subtract 6 first to make it equal to 0, and then you could think about factoring. Make sense? Okay. So again, on the test on Friday, we're going to have 5 equations that we need to solve, 5 out of 20. Okay, so you need to first make sure that you do have an equal 0. If you don't have an equal 0, make it equal 0, and then you factor. Now, some of them will be very easy because some of them will not have this a value of 2. Some of them will just say like x squared, and you think, oh, what times what is a c value that if I combine together is a b value? Unfortunately, this one does have a 2 right there. So we're going to have to use the long process. Step 1, a times c. What's a times c? Negative 6. Okay, step 2, let's think of the multiples of negative 6, like negative 1 times 6 or negative 2 times 3. Which pair of numbers gives me 5? Negative 1 and 6. Go through each one and just add them. Oh, if I add negative 1 and 6, that'll give me a 5. If I add these guys, it gives me a 1, so that's not it. It has to be the negative 1 and 6. So step 3 is to plug it into your factored form format. And of course, we only put the 2x right here and right here. We don't put 2x squared. So let's put that 2x right there. And what goes in these blank spots right here? The negative 1 and the 6, right? The negative 1 and 6 go right in there. There it is. Okay, so since I do have this as a factored form, it's still wrong. Because if I were to distribute 2x times 2x, I'll get 4x squared, not 2x squared. So I need to do step 4, which is to reduce each binomial by its GCF. Now, the first binomial does not have anything in common, so you don't worry about it. The second binomial, there's a 2 and there's a 6. What could I divide by? 2. Divide by 2 and divide by 2. So like we said, the first binomial stays the same, 2x minus 1. The second binomial becomes 1x plus 3. And then you bring down the 0. And then you could split them and solve. So I wrote each of those binomials, set them each equal to 0. Now we're going to solve plus 1, 2x equals 1. X equals 1/2. And on the other one, subtract 3, x does equal negative 3. So those are your two answers for that one. So that's pretty much a review of everything we've done so far. Let's go back to the first page, guys. Because we have this new section right here, factoring, perfect square, trinomials, and binomials. So I'm actually going to pick this up on the second video. I'm going to stop right here.